So 9. Let S be A, B, C, D. So this is our sample space for some experiment. Doesn't really matter what the experiment is. Okay. Now we just were asked for B. So suppose that the events E, and so E consists of sample points A and C, and F, consisting of sample points C and D, are equally likely, and that E intersect F complement is 0.3. If outcome C is only 3/5 as likely to occur as outcome B when this experiment is performed, find the probability of F. Okay, so they're giving me some weights here. They're telling me some nice verbal information. So equally likely is something that translates to, when I work out the probabilities of E and F, they should be the same amount. So this question, this 9b here, is just giving me a whole bunch of information in disguise, and it's up to me to translate it. Now, because I know what sample points are in E and F, I can rewrite these in terms of the probabilities of the individual weights. Okay, so the probability that E occurs is the probability that A occurs plus the probability that C occurs. F was just C and D, so I've got this information here. Okay, so this is something I know for a fact. Okay, so they're equally likely. We also know that E intersect F complement is 0.3. Hey, what is F complement? Well, I know the whole sample space is A, B, C, D. Okay. So F complement is the things that are in S but aren't in F. So that's just A and B. E intersect F complement is what? Well, E is A and C, F complement is A and B. The only thing they have in common is just A. So when they say the probability of E intersect F complement is 0.3, well, what's this probability? It's the sum of the probabilities of the weights. So somebody was just being very sneaky and told me the probability of A is 0.3. Okay. So now one thing I could do is I could take that and plug that back in up here. You can actually work out the probability of D is 0.3 as well. Okay. Maybe we'll have to do that in a moment. What else are they telling me in this question? C is only 3/5 as likely to occur as B. Okay, so some more natural language that is giving me some coded information. Probability of C is 3/5 the amount of probability of B. Okay, so we're starting to relate certain things to each other. Okay, certainly the probability of A we actually know, but C and B and D, what else can we do? Okay. So I think now might be a good time, not that you have to do it right now, but now might be a good time to say, well, I just did work out the probability of A. I know it's 0.3. And I've got probability of C on both sides. So whatever it is, if it's 0.6 or if it's 0.1, whatever it is, I can just cancel them out on both sides. Just subtract probability of C from both sides, like an algebra problem. And what is that left with? Well, that shows me the probability of D is also 0.3. So probability of A is 0.3, probability of D is 0.3. And because we know that the whole sample space consists just of A, B, and C and D, what do we know about weights? The sum of the weights is always 1. Because the probability of the sample space, which contains exactly the sample points, probability of S is always 1. Okay, so we've got 0.3 here. I don't know what the probability of B is. You know what? I don't know what the probability of C is, but I do know it's 3/5 the probability of B. And I know the probability of D is 0.3 as well. Now, depends on really your perspective on life, whether or not you're a decimal person or a fraction person. I'm a fraction person myself. So I might change these 0.3s into 3/10. A different person would say keep the 0.3, change this 3/5 into 0.6, but I do recommend you either do all fractions or all decimals, just to make your life a little bit easier. So 3/10 plus 3/10 is 6/10. And then I've got 1 probability of B plus 3/5 a probability of B. Okay, so I could factor out the probability of B here. I'm left with 1 is 6/10 plus 1 plus 3/5 probability of B. Subtract 6/10 from both sides. And then I really should work out what 1 plus 3/5 is. Well, 1 is 5/5. Okay, 5/5 plus 3/5 is going to be a total of 8/5. And 1 is also 10/10. So 10/10 minus 6/10 is going to be 4/10. And you know what? We can divide top and bottom there by 2. So 4/10 is really 2/5. And then if I want the probability of B, just divide both sides by 8/5. That goes away. How do you divide fractions? You invert the second one and you multiply them. Okay, the 5s will cancel out. We'll be left with 2/8 or 1/4. So the probability of B is 1/4. Or if you're a decimal person, you could have done 0.25. Okay. So I know the probability of A, I know the probability of D, I know the probability of B. What were we even asked for? Find the probability of F, so I need that probability of C at some point. But that's okay. I know the probability of C is 3/5 the probability of B that I just worked out. So it's going to be 3/20. Okay. Or you could say, you know, if you're a decimal person, 0.15. Probability of F is probability of C plus probability of D. Okay, so that's going to be 3/20 plus the 3/10 we had earlier. Get a common denominator and you'll get 9/20 when all is said and done. Okay. Or again, you know, if you're a decimal person, 0.45. So that would be 9B there. And we can move on to 9C as well, just while we're here. So we've got wholly new information. It's known that the probability of C is K times the probability of A plus the probability of B for some positive integer K. And that event E is A plus B, and the probability of E is 1 over 2 plus 2K. Find the probability of D. Okay, so this is going to be another sort of algebra hunt. So E consists of A and B. They're telling me that in the question. Okay. Now, I did already see probability of A plus probability of B somewhere in here. So that's kind of interesting. All right, and they tell me that this specifically is 1 over 2 plus 2K. Right, that's a little bit of information I've got. Now, what do we know about the probability of C? Just putting all the information in here. It's K times probability of A plus probability of B. But I just found out that that's 1 over 2 plus 2K. So the probability of C is K over 2 plus 2K. Okay, so I know the probability of C, I know the probability of A, I know the probability of B. Well, sorry, I don't know the individual probabilities of A and B, but I know their sum. What else do we know? Well, actually nothing else other than K is an integer. And what do I want? I just want the probability of D. That's all. Can I just get that? Okay. Well, again, we know that A, B, C, and D are the only things in my sample space. So their weights should add up to 1. Now, I don't know A and B individually, but I know together they are 1 over 2 plus 2K. And I know that C is K over 2 plus 2K. And then there's the D that I don't know. But, oh, these fractions have a common denominator, so we can add up their tops. And at this point you might say, oh gee, I'm a little stuck. Yeah, what do I do? I don't know what k is. I can't simplify this anymore. Not so, my friend. Not so. The top has a 1 and a k added together. The bottom is 2 times the 1 and the k added together. So it doesn't really matter what k is. Okay, we can simplify it. So 1 is equal to, this whole thing is just 1/2. Probability of D is going to be 1 minus 1/2. Okay, better known as just 1/2. Okay, so it does not matter what k is at all. Everything works out, and the probability of D is 1/2 or 0.5. Okay, a very interesting little question there.